So if I look at my simple circuit here, I've got a power supply, I've got wires, and I got a light bulb. Okay, that is the simplest circuit you can have. Okay, it's only got one object that's using the electricity. We will actually build up to having more than one object set up in a variety of ways. Okay, but for now, to kind of understand the different concepts here, we're just going to look at this simple circuit. And the first thing we're going to talk about in a circuit is the concept of current intensity. Okay, when I say the word current, what do you think of? What does it make you think of? A what? A wave. Anybody else? Yeah? Okay. When I say the word current, do you know what I think of? I think of a river. And I think of a river moving very, very quickly. Right? It's got a really thick current. It's got a fast current. And if I was to try and walk across that actual river, it would be hard. I would get swept away, right? Does that make sense? Can you picture that? Now, when we talk about the concept of current in an electrical circuit, we're kind of talking about the same thing. We're talking about the amount of charge that moves past one point in the circuit at any one time. Okay, so if I want to measure, if I want to know what the current intensity is in my circuit, I want to basically say how many coulombs are passing through that point where I've made the X at every second. So 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. Every one of those seconds, how many actual coulombs went through that wire? In other words, how many electrons went through that wire at that time? Because we know that 1 coulomb is equal to what in electrons? 1 coulomb is electrical charge, but it's equal to 6.25 times 10 to the 18 electrons. A lot of electrons, right? Now, here's the deal. For every second that this circuit is operational, for every second, so 1, 2, 3, at every second in time, a certain amount of coulombs is passing through my given point right here. Okay? So in other words, if I want to read how powerful my circuit is, how much energy is in my circuit, how many electrons are in my circuit, okay? Because when I say current intensity, the intensity of something is how much of something there is, right? If you are way more intense than you are, well, you're more into something, you're more focused, you're more driven than, let's say, somebody else is who's less intense. Here's the deal. For every coulomb that passes at a specific point in a circuit every second, okay, we actually have a specific unit for that. And that's what we talk about when we're talking about current intensity. So at this little spot right here, wherever my X is in this circuit, if every second I'm counting how many coulombs go through there, I can determine how intense my current is, right? And the more power I have in my circuit, the more current intensity I'm going to have, right? The more power my power supply is spitting out, the more electrons are moving around. So the higher current intensity I should have. So if we say that current intensity has to do with electrical charge and time, we know that electrical charge is measured in what? What's the unit of electrical charge? Coulombs, right? Coulombs is electrical charge. And if I say that I want to measure how many coulombs are passing through that X every second, I can make a fraction out of that, right? Coulombs per second. Do you see that? Well, the concept of coulombs per second is actually equal to something called an ampere. Okay, an amp. All right? So an ampere measures the amount of coulombs that pass through a spot in a circuit every second. All right? And here's the deal. When we have an actual circuit, and we want to measure current intensity, instead of having a little X there, we actually have a machine whose job it is to actually measure the amount of coulombs per second that are actually going through this circuit. And this little box, okay, and I'm going to draw it in red here because most of our actual ampere readers are red. So I want you to get used to those colors. Okay, so this little reader here has a wire going into it on one side and a wire leaving it. And its job is to measure how many coulombs actually pass through this box every second. Now notice how I've actually made this box part of the loop, part of the actual circuit. Okay, this is called an ammeter. And I'm going to do this in red. And an ammeter registers how many amps of current you have going through your actual circuit. Okay, so an amp, if you remember, is how many coulombs every second. So 1,000, 2, 1,000, 3, 1,000. Every second, it's taking a reading of how many coulombs there are. And what do coulombs represent? What do we remember about coulombs? Coulombs represent only the number of electrons in a charge, right? For every 1 coulomb, 1C equals 6.25 times 10 to the 18 electrons, right? That is a big number of electrons. So if I'm calculating how many actual coulombs pass through every second, I'm actually calculating how many electrons are running around in my circuit, aren't I? I'm calculating how many electrons are running around in the loop. And if we look at the definition of current intensity, we're actually looking at how much charge is passing by a point in every second. How many amps of current intensity there is running through that circuit. And here's the cool thing about an ammeter. I say that, I look at this circuit and I say that this is a circle of friends. Okay, we've got one friend here. This is the power supply. And that friend provides the energy. We've got, this guy is a light bulb, also known as a resistor. Okay, and a resistor is going to make something happen. Okay, in this case, this is a light bulb. And then we've got our ammeter here, right? All three of these things are part of this actual loop. If you notice, okay, the actual loop actually starts here and it makes its way all the way back and then it keeps going. And it just goes and goes and goes until we actually break this loop, until we break the circuit apart. It will continue to actually work, okay? So the ammeter, the resistor, and the power supply are always part of the circle of friends. They're always in a circuit loop. And here's the cool thing about current intensity. Okay, from a mathematical point of view, it is a 3-variable equation. All right? Current intensity, I for intensity, is equal to Q over delta T. Wow, that's confusing. Ugh, I don't like all these letters. I don't know what they mean. But here's the deal. If I'm telling you that current intensity is is the number of amps in a circuit, what is 1 amp equal to? What is 1 amp equal to? Number of coulombs per second, right? If I say that 1 amp, 1A, right, is going to be equal to the number of coulombs per second, and I'm telling you that A represents the intensity of the current, I already know what my units are here. If 1A, remember, A is equal to the number of coulombs per second, right? Q is also known as your charge. What do you think the charge's units are? Electrical charge, what is that measured in? Coulombs. What do you think time is measured in? Is measured in seconds. What do you think current intensity is measured in? Amperes, amps. So if I look at this, if I'm trying to measure the current intensity in a circuit, I'm saying how many coulombs pass by this spot right here every second. 1, 2, 3, 4. I'm getting a reading of coulombs. I'm getting a reading of the number of electrons passing through that ammeter at any second in time. And that is given to me in the form of a number that I read off this machine, this little red machine. Okay, it's got a little gauge, and depending on how many electrons are running through it, it's going to give you a number. And you need to read it off the gauge. Okay? If we're calculating current intensity, we need to have 2 of these 3 variables. All right? And the cool thing about this is that you can rearrange this actual equation to find the amount of time you need, the amount of time that a certain charge will give you in amps, or you can rearrange it for the charge. Okay, and unfortunately, as we go through these actual equations, you're going to see that some of the letters that they use to talk about the different things, they don't really add up. Like, why is Q the letter they chose for charge? Q, little q, has nothing to do with actual charge, right? You'd think that charge would be in coulombs because it's a C. Yes? Unfortunately, that's not the way whoever invented this decided to roll with it. So we've got we're going to make a table as we go here, and we're going to make a table of the name, the actual unit, and the actual symbol that is used for that unit. Okay, so if we start off here, I stands for current intensity. And it is measured in amperes, right? Q stands for what? Q stands for charge. And I would accept electrical charge there because that means the same thing. What is Q measured in? Coulombs. And then our last one, delta T. Now delta, the triangle, just means the change in time. Usually time will just be given to you. Okay? Time is always, for these formula, time is measured in seconds. So if you're given something in minutes, do you know how to go from minutes to seconds? Yeah? Some of you do and some of you don't. Okay, so when we start working through these problems and examples of these problems, we're going to go over how to actually convert. All right?